Thank you. At the risk of oversimplifying, the question that we're trying to answer with a remote attestation is just, is my conversation partner running good software? And when you're faced with this question, you wonder, what is good? Okay. The IETF came up with this framework that's informative, that describes all the different players in providers of information for determining what is good. And this talk is primarily about the endorsements and reference values that go into the verifier. This embodies supply chain ecosystem information. And to make them meaningful, we have attesters that are providing measurements that closely match our formats for describing what are the measurements that we want to see. Now, we go from informative to normative when we talk about the coming standards for CoRIM and concise evidence. So CoRIM is this supply chain aspect of how to describe reference values that we want to see from measurements and additional qualities that aren't necessarily measured but are value add statements. And I will say that there is a lot of interest in getting a single format that we're all talking to each other. And the Open Compute Project has a lot of different silicon and device vendors coming to represent things with concise evidence. Now, there are normative transformations that we've defined to translate from, say, SEVIS and P attestations and Intel TDX quotes into concise evidence so that you can still provide reference values in this new format that we're coming up with. Right? So this talk is primarily about CoRIM, right? How do we create them? How do we get them to users? And how do we allow users to interpret them effectively? And when you're at the global scale, you don't want to have to start from scratch. So there is already a very large open source software ecosystem for handling build attestations. That's one aspect of software supply chain integrity. And I think that we can very easily add in our own concepts to expand their scope and not terribly disrupt the projects and benefit by having these open source projects provide the building stones for anybody to provide their own services for providing reference values. Right? There are a lot of existing projects already that I propose that we go and add our concepts to. And we'll start in the build service. There are also projects for doing online analysis to find problems. There's also a service for providing attestation documents to anyone who's interested in listening to the topics of updates on those artifacts. And then when you have all of your information gathered into one place, you can interpret them in a simple manner by depending on a normative data model. All right, so the Entotos ecosystem is rather rich. So we have lots of different projects that are out there, and I think for the distribution aspect, I think we've already heard from Paul Howard about the endorsement API earlier this morning, that we want to have the ability to query for these specific documents, and we also want to be able to subscribe to topics when there are changes. So if there is some kind of security advisory, we are notified rather than having to continually search for where problems might be posted. All right, so let's start with what is CoRIM. I don't want to go too deep into the format specifics, but generally it is this document that or message that is signed by somebody, and the message carries tags. These are manufacturing tags that are basically saying that whoever signed the document makes claims about a particular environment. So X is some manufacturer claims are like, oh, this is 100% polyurethane, and the environment is the actual thing that we're talking about. Okay. And with the specification for CoRIM, we're also specifying a normative process for understanding those reference values against the evidence that is coming in from attesters. And we augment them with information about who said what are the additional endorsements that you've learned, so that your policies can take those augmentations further. So I think that a really strong aspect of CoRIM is this tag called COMID for module identifiers, where the subject of an attestation is an environment. It's not just software. So we have a description of those environments with a class of attester, and this is within a global namespace, and it's designed to allow you to be to not have to contend with all the different actors in the world. It's rather simple to come up with a unique name. You can talk about very specific instances of that attester if you indeed have particular deployments in the field that have their own special claims that you need to associate with them. And if you want to keep things anonymized, there's a way of grouping them. Okay. Within a COMID, the statements that they carry are what they call triples. The triple is that you have a subject that is bound to an object through the notion of a predicate. So some examples are evidence binds an environment to measurements as evidence. You have similarly an environment bound to measurements as reference, and then you can have measurements, really claims that are not necessarily measured, that are bound to an environment as endorsed properties about that environment. Now, the claims that we talk about are standalone. You have the name in your hand. It's not going to be contextualized based on what else you've measured in the environment. You get to know just exactly what it is that you want to compare against. So an example of a class ID is like an implementer of an ARM CCA architecture. So for instance, Google chips might have an ARM chip, and we will have our class identifier as the instantiation here. And then the attester measures all of these different aspects of binaries that it loads during boot. So the version, the digest of the binary that it's loading, and indeed the signing key for that binary, all are extracted from the binary and put into this measurement that becomes part of the platform security token. Right? So contrast to this notion with event logs, where you need to do some complex analysis to parse those event logs and make sense of them. If you want to make sense of event logs in the lens of CoRIM, we should talk outside of the context of this talk. It is rather rich. Okay, so let's take a look at what we mean by augmented evidence. So let's say we do have events, right? And those are bound to a TPM quote with its PCR measurements, right? So the quote is signed by a key that we bind to the underlying confidential compute VM that itself measures the virtual firmware that we started the VM with. And we also have information about the host firmware that is supporting the confidential VM platform. And we need to know what are the reference values for each one of these. And it's not always going to be known or provided by the same person, right? So we'll have Silicon PKI describing this key. You might have some watchdog organization that is saying what are the good security version numbers that you should be paying attention to. This firmware, the virtual firmware, might be provided by your cloud service provider. I did the firmware signing for Google. Aspects that you also measure, things like EFI drivers that you're booting. And then you finally get down to your operating system and the initial user space. Okay, all of these things are expressible with CoRIM, right? And we say, okay, here is a measurement. We're going to say who signed it, and we're going to provide a data model for your policy to understand it. Right? And there can be events that you leave for your policy to understand that don't necessarily have to be matched against the reference values. And so your policy can be as simple as saying, who do you want to have said what about particular events? Now, RATS is also coming up with other ways of normatively expressing who you trust to make particular claims. And it's called the concise trust anchor store. I won't go into much more detail about that in this talk. But the more that we specify in standardized means in CoRIM means we have less need for policy languages that are bespoke. Now, Open Policy Agents RAGO is a nice language, but it is not a standard language, and it makes that kind of policy portability difficult to move across platforms. Right? I would say that we don't have the ability to make reference values for individual events. I would say that secure boot might be counterproductive. We should talk about that in a chat room sometime. If we do want for these events to more easily match reference values, we need the ability to innovate on our firmware for what it is that we're actually measuring. And I do like the Red Hat project to bring custom firmware to the cloud. I think that we're going to see more demand for that in the future. Okay, so let's talk about creating these CoRIMs through build service. All right, so in Toto is this system of creating build attestations, and in Toto is this way of providing statements about your supply chain. And lo and behold, it looks very much like CoRIM triples, where we have subject, predicate, and object. An instantiation of an in Toto statement is something like salsa provenance, the supply chain levels for software artifacts, where we say that there's a certain level of hermeticity of your build environment, and you know all of the inputs to that build. You get to know the Git hashes, etc. And so there's not just salsa. You might have these software bill of material that you generate, but then while you're building, you come up with this question. It's like, is your builder really building with the tool chain that you expect? And this tool chain is such a bother. So if you generalize a little bit, you're talking about remote attestation again, when you have to prove that you're running the expected tool chain. So our worlds are colliding between CoRIM and in Toto. And it is ongoing work with the Salsa folks. Marcelo Molara, specifically at Intel, has proposed a predicate in Toto to extract particular attributes about build objects as provided by a producer of information. So you can say, I am a producer of firmware measurements, and here is my CoRIM as evidence, for example. Now, some producers that we would want to plug in here already exist. Verti project, the IGVM measure, IGVM being the format for loading firmware. Systemd measure is another one of these things. The pieces are all here. We might need to build a few more for things, for bootloader aspects like grub2. But again, I say that probably custom firmware where we can simplify the build chain is probably where we want to go. Right? So it is, we still have a lot of pieces to build. Google would be approaching this from the container optimized OS so that we can give reference values for how we're booting up nodes for Kubernetes, for example, or our cloud for our confidential space, right? And Ijla on the other stage, very willing to work with us on how to use these standards that we're producing for operating system distributions, for their operating distribution to provide reference values to the supply chain ecosystem. Right, so when we build COS, we have this build service called CoCro RB. It's not particularly important, right? So after build service, we have the environment analysis. There is a lot of quality signal that you want to associate with components of your platform, like, can I really trust this? There are lots of things here. And I would say that most of these qualities are not things that you want to individually check for at runtime. You want to assemble all of this information offline from your knowledge base, determine whether that is going to be good for your own deployment, and then use that as a policy for assigning reference values as this is a good whole package, right? We've heard from NVIDIA on ways that they're doing that within RAS. It's a whole topic in and of itself. Right? So there is already this project called Guac for analyzing information from the supply chain. And here we would want to say, here is a system composition, not just a software composition or SBOM, that says, I have these GPUs on this firmware and this operating system. Please tell me what you've learned from the whole ecosystem, what is good and what is actionable, what is something that I need to teach my platform for them to go and fix. Right? The platform itself, not just the software, is a dependency that we can use that we can talk about as an input. Right? So we have all of these CoRIMs. We need to get them into users' hands. Right? So there is a project out there already called Archivista that has a database backend that allows you to have PubSub to listen for updates, right? You get updates as they happen. And Archivista, if we're adding in CoRIM the notion of an environment, naming the claims, this can be like the cookie cutter way of providing replacements to these already existing systems that have their own APIs that could be generalized to a more standard platform. Again, it's back to the endorsement API idea. And if you didn't see Paul's talk, I would recommend looking for the recording. Right? So there are aspects that are negative that you want to collect in this knowledge base, and there are also positive aspects like this set of chips is in this particular zone, this geographic information is important for regulation, that kind of thing. Right? And by using this open source software and listening for the information that you want to get, you can populate your own version, your own instance of the software to have more local copy for reliability. Right. I will say that Archivista is meant for like archiving things, but when you have endorsements, they're going to have shorter lifetimes. So you do need to keep in mind the notion of time to live. So that's something that we would want to add to Archivista. But we do already have this product in Google Cloud called Artifact Registry. They've recently added the notion of a file attachment. So we can say that, all right, here is some binary artifact, and we've attached such and such endorsements. It's going to expire in a few days, but we've found that there's no problems with the latest vulnerability scan, or the latest security version number of this is whatever, or there's particular CVEs that are associated with this. That kind of endorsement is something that we'd want to continually attach to artifacts. Right? So cleanup policies, important thing to keep in mind. Right? So you have it out there. How do you get it back in? We're thinking about a normal release to production pipeline. You're constructing your system. You sign your composition. You roll it out. You check your signature before you run anything, and you allow yourself to talk to other aspects of production. Well, that's your a priori information. If you have some other information that comes along later, you want to assimilate that with your analysis, right? You'll create your policy from that knowledge base. And when production says, hey, I would like to refresh my credentials, here's my evidence, you give back a short lifetime certificate that says, you're still following the governance policy that we have for production. So continue to communicate with other players in production, right? This signing part right here, this can be where you are actively analyzing information coming from the knowledge base so that you don't take down production with information that says, oh, you actually shouldn't be trusting your own software. But this also gives you an opportunity to say, well, if I'm just rubber stamping things, I'm at least creating a point in history for auditing. Okay. So we have it in our hands. How do we act on it? Right. So if we're thinking about all of this augmented evidence, we want to have a general purpose attestation verification service that isn't necessarily just run another VM that's running like in a completely different general purpose computation. It's a bit too heavy for accepting connections, right? So as a middle ground, I think that we just want to follow some turn the crank ideas to produce maybe this internal representation that we're expressing in the CoRIM specification. But then you're tasked with the question, like, which CoRIMs am I putting into this meat grinder, right? So this when you have the CoRIMs in hand, you get normative structure that you can follow in your definitions of policy to check, did Google sign this? Did NVIDIA sign this? Did ARM sign this? Right? Now, it remains to be seen how we want the execution to work. Right? Are we going to have our little database where you can say, I'm going to query for a particular environment and claim and signer and get a response back and have a quick interaction like that? It remains to be seen so far. If my colleague Josh were here, he'd have some things to say about that. Right? Well, I think that we're going to have our evidence and a name of a policy that we provide to Attestation Verifier Service. And that policy will carry with it what is the RAGO policy that we want to evaluate, but not only, but also a small database of reference values that are bound to that policy so that it can query. Right. I'm not running out of time, so I'll just leave you with these takeaways that that in toto is the way that we're going to. I think that we want to scale up the use of CoRIM to go from just build attestations to whole platform attestations. Thank you.